In a world filled with fierce anemone enemies.
You don't understand the gravity of the situation!
Holes in graphs.
Hole in the graph. Hoo ha ha.
And jump discontinuities. Who will lead us in finding continuity? Coming to theaters in 0.6239 seconds.
You forgot the negative!
Hi everyone. Remember a few videos ago when we were talking about limits and continuity? We're going to talk more about continuity today. So, you can find continuity a bunch of ways. We're going to start out with the basic graphical representation of it. Now continuity is, in the most basic sense, a graph is continuous if you can draw it without picking up your pen off the page and without any breaks or holes in the graph.
Just keep drawing, just keep drawing the graph.
The formal definition of continuity states that at a certain point, it has to be defined at that point. The limit has to exist as you approach that point from both sides, and what that limit is as it approaches that number, and the value of that point have to be the same thing. So, say you had a graph like this. You can see if we were to take the limit as you approach this point, A, from the left, it would be the same value as if you approached it from the right. Let's call that value B. And if you were to take the function value at A, as though, if this is f of x, f of A would equal B. And I already said the limit as x approaches A equals B. Now, since the function value at A is equal to the limit as x approaches A, then of f of x, then we can say that the function is continuous at that point. Let's look at some examples where the function is not continuous. Say we had a graph that looked something like this. Now in this case, the limit exists as you approach A from both sides, but the function value is undefined if you tried to take f of A at that point. So since the function value is undefined, it is not continuous at that point. So the other common discontinuity that you'll come across is a jump discontinuity, which looks something like this. It could be defined at or not defined at those points, but the whole point being that the limit as you approach this value A, as you approach that x value A from the left, is not the same as the limit as you approach it from the right. So in this case, since the limit doesn't exist, it's not continuous at A. Now, remember that I said the three rules of continuity are f of A has to exist, the limit as x approaches A has to exist of f of A, and these two things have to be equal. So in this case, if we look at this graph, as we approach, this is f of x, as we approach A from the left, it'll equal the value B. If we approach it from the right, it equals the value B. So, the limit as x approaches A of f of A is B. The function value is also defined at A. Let's say that that's C. But
He touched the butt.
C and B are clearly not the same thing. So the statement that f of A equals the limit of f of A as x approaches A is not true. So the function is not continuous at this point.
Brilliant.
Now it's important to be able to do the math behind this, because sometimes you don't have the graph or it's not something that you can graph. What this problem wants us to do is to find a such that this function is continuous at x equals 2. That's a piecewise function. A lot of these functions that have to do with continuity are piecewise functions. So in this case, now let's remember our rules for continuity. F of c has to be defined. The limit as x approaches c has to exist. And these two things have to be equal. Now if we want the function value at whatever number it is, in this case c equals 2, if we want that to be the same thing, we want that to exist, well it does exist, and it is going to be given by whatever this function is when you plug in x for 2. It's going to be 7. Now, this part of the function has to have the same y value because in order for the limit to be the same from the left and the limit to be the same from the right, it's going to have the same y value. So we're going to set this equal to 7. And remember, as we said, x equals 2. So we're going to plug in 2 for x. We find that 2a equals 6 and a equals 3. Now, let's double check that we got the right answer here. If we change this a to a 3, because that's what we do when we plug in 3 for a, the function value at f of c, where c is 2, because at that point x equals 2, we're going to plug that in and we get 7. So the function is defined at x equals 2. We have to find the limit of the function as x approaches 2 from the left and from the right. So the limit as x approaches 2 from the left is going to be of this function, because that's what it is to the left of 2. It's going to be 7. Now if we approach this function from the right, it's going to be this function, because that's what it is when x is greater than 2. This one is 7. So, now that we've found the limit as you approach from the left and the limit as you approach from the right, they both equal 7. So we can say that the limit of this function as x approaches 2 is 7. So the limit exists, the function is defined, and the function value and the limit equal each other. So the function is continuous at that point.
Just keep swimming, swimming, swimming. Just keep swimming, swimming,
We're going
swimming.
to find out if this function is continuous where x equals 3. So let's remember our 3 rules for continuity. 1, the function has to be defined at the x value we're looking at. 2, the limit as x approaches that x value of the function must exist. And 3, those two must be equal to each other. What is the function value where x equals 3? C equals 3. Let's find that first. If we look at our piecewise function, it is defined such that when x is greater than or equal to 3, which it is equal to 3, this is the function that describes it. F of 3 is 3. Now let's look at the limit. So we're going to find the limit as we approach from the left and as we approach from the right and see if they're the same thing. As we approach the equation from the left, it is going to be this function, because that's what it is when x is smaller than 3. So 3 to the 3, that is 27. So that is the limit as you approach it from the left. And the limit as you approach it from the right That is 3. 3 clearly does not equal 27, so the limit does not exist. So since the limit does not exist, the function is not continuous at that point, because all 3 of these statements have to be true. Now, if we were to look at this graphically, we could see it another way, that it is not continuous. From 0 to 3, the graph is the graph of 3 of x. That graph looks something like that, with a hole at the top of the graph,
Hole in the graph. Hoo ha ha.
leading up to the point 27. This is a really rough sketch, not trying to scale. And from when x is greater than or equal to 3, it is the graph of 2/3 x plus 1, if you can imagine it coming up like this. If you look here, we have a jump discontinuity. The graph is clearly not, you couldn't draw this without picking your pen up off the page. So, yet again, the function is not continuous.